Hello, I want to charge a battery from a battery, and as part of that project I'm going to take a look at this thing. It is a charge controller stroke discharge controller. It is the XY CD63L, and this one was very kindly supplied to me by icstation.com, so I will put a link to this item on their website in the description below. So let's have a little look at what's on here. Well, very clearly there's a relay. It's a 5-volt coil relay, 30 amps rating, 250 volts AC or 30 volts DC. Here there's a little switch mode buck regulator with a diode and an inductor. So it's a little power supply. There isn't a lot else. On the back there is an LCD driver for this liquid crystal display. That's still got its peel sheet on. I'll take that off in a moment. And there's a microcontroller there, and that's the programming header for the microcontroller. Otherwise, there are a few discrete transistor there, which is probably the relay driver. What's this thing down here? Well, it says on it M5433B. Now, I'm pretty sure it's a regulator. I can't find a datasheet quickly which gives me that marking. The 3.3 on the end kind of hints at 3.3 volts, but I can't be certain about that. But yeah, pretty certain that's a regulator. So yeah, not a huge amount on here. So what I want to do is start by powering this up on its input pins. You can see V in plus minus and out plus minus, and I'm going to do that with a battery. So I'm just putting a couple of connector leads on here so that I can just shove a battery on there quickly just to see what this thing does. I'll just get these nice and tight. Right, okay, so I've got my little pieces of wire on there. Okay, let's put a battery, so positive to V in positive. Battery on this side. Can we see it down on the bench? Yes. That's going to keep happening, isn't it? But I'll try and prevent that from happening. Right, so what do we see? The first thing we see is in. Now, in, these are generic LCDs, and in is slightly convoluted meaning for charge controller. So you're controlling the charge from a battery charger on the input to a battery on the output. Now, we don't have a battery on the output, and that's why it's saying NBE. In the manual it says, I think, no battery connected, but why E for connected, I don't know. So I'm going to call it no battery encountered. So no battery encountered. Let's encounter a battery. It's that way around. Whoops, that's me disconnecting the input. And if I do that, then we encounter a battery. The voltage is 9.6 volts. And ignore 100% for the moment. It's a little bit complicated what that means. So it has now encountered a battery and it's 9.6 volts. If there's no battery on there, you get 0 volts and NBE. Now, like I say, this device has two distinct modes and you can switch between them. But the video will get very long if I try to cover both modes in this video. So I'm only going to concentrate on the first mode. That's battery charger or charge controller mode. And that's when the display has that little in symbol on it. The other mode, which is discharge controller mode, the display will have out. But we're going to do battery charger mode in this video. So what I want is a battery charger. Now, all that means is that it's a current limited power supply. That's upside down, actually. So this is a current limited power supply, and I'm going to have a battery. I'm going to have this lead acid 12 volt 2.3 amp hour battery. Let's get some connectors and wire this up. So I've made up connectors specially for this. These two are for the battery, and I've put a fuse in there. It's 5 amp. It really should be a bit lower, but that'll do just for ultimate protection. Cable to go between my battery charger and the charge controller. I'll take these little wire links out and get all the cables connected now. Right, I've connected the current control power supply to the input of this device. Let's switch on my power bank. Now if I'm to charge a 12-volt battery, these things can go up to about 14, so I think I'm going to raise this up to 15 volts like so, and we'll current limit it to a bit more than that. Let's current limit it to 1 amp. Okay, so 1 amp, 15 volts. So if I switch on the output of this, the 15 volts will go into this unit. Now this, I believe, has a range of, well, let's look it up. Yes, this has an input voltage range of 6 volts to 60 volts. The main regulator I see here, switch mode regulator, is an XL7005, so that's where they get the 6 to 60 volts input voltage range for this thing. But it's very handy because it means that you can charge control batteries of a reasonable range of voltages. So we've got 0 volts on here. It doesn't tell you the voltage of the input power supply. It tells you the voltage of the battery. We've got no battery encountered, so let's encounter a battery. I made these leads up. Let's hook them on. So that's the negative lead. Screw that in there. And now I'll attach the positive lead. Do this with some care because I don't want to touch that positive onto the negative and blow the fuse. So let's get that in there. Tighten that down. And now we have a battery encountered. Oh, these wires are going to keep moving this thing, aren't they? Perhaps I'll get a bit of blue tack. And you can see that the battery voltage is 12.2 volts. So what we need to do now is get this relay to switch on. That links the positive to the positive. That means that this power supply will start charging this battery. It will immediately go into current limit at 1 amp. I've just switched it off. Let's turn it back on. Currently it's only taking a very tiny current, enough just to light up the LCD and run the microcontroller. But yeah, let's get this thing to now switch on. So the way to do that, let's put this back on voltage, is to set this thing so that the lower voltage, you set an upper voltage and a lower voltage. The lower voltage is the point at which the relay switches on. The upper voltage is the point that the relay switches off, and it will simply switch on and off, and the battery will go to the upper voltage, to the lower voltage, and simply oscillate, I suppose, between those levels. So if I press this middle button, we can see the upper voltage, the down voltage, and then you've got two other parameters called op and dop, and those are timers. So press and hold the middle button and we can set the parameters. So the upper voltage is the voltage that we want the relay to switch off when this battery gets up to. Let's go for something like 14 volts for that. So that takes a little while to cycle up to that. Oh, it's sped up when it got to a certain point. Well, I don't really want that, do I? So back down to 4. And the flashing on and off thing does make it quite difficult to catch it just right. But okay, so 14 volts for the upper parameter. The lower parameter, I'm going to say, well, we could have something like 11 volts, but the problem with that is it's just going to take so long to go between 14 volts and 11 volts that we'll never see anything. In fact, with the battery, we're not going to see anything anyway. But what I want to do is get this thing to start charging. So I will set the lower voltage to 11 volts. I think it said it was 12.2, didn't it? No, I really need to set the lower voltage to something where this will start charging it. So I think I want this device to see that the battery is at a low voltage. So I'm going to set the lower voltage to 13 volts. So it will simply charge from 13 volts up to 14 volts and then allow it to discharge. Press and hold to save that. And the relay switches on. And we can now see that it's oscillating on and off, because when I put my 1 amp current limited power supply onto the battery, it immediately shoots up to my upper limit of 14 volts. And then when that's removed, it immediately drops to 13 volts. Now, if I lower the current, which is here. So let's lower the current to say 500 milliamps. We can probably stop that oscillating because that current is not going to push this so high that we hit the upper limit. In fact, you can see it's pushing it up to 13.7, and it's only when we get to 14 volts that the relay will turn off, and then when the battery falls back to 13 volts, the relay will turn back on. Now, of course, with this low current, we're not going to see what's happening, so I need to raise the current bit by bit so that we can see the effect. So 13.9, it gets to 14, the relay turns off, it immediately falls to 13, and the relay turns back on. Unfortunately, the switching of this display is not fast enough that we can really see that. The other thing this does is after a charge session, it blinks the display, which is quite annoying really. So I've now set it to 550 milliamps, and it's going at a slightly more sensible rate. So get up to 14 volts, the relay switches off, which is that point. I can stop the flashing, but yeah, we're still not actually seeing the voltage on the display because it hasn't got a particularly fast refresh rate. But yes, this is what the relay does. It simply has an upper threshold voltage, a lower threshold voltage, and you can get it to switch on when it hits the lower and off when it hits the upper. So it controls the charge of this battery. Now at the moment it's taking quite a while to push it up to 14 volts. The in symbol incidentally flashes when it's charging, and the red light is on when the relay is on. So those two things tell you that we're charging the battery from the current limited power supply. When this hits 14 volts, of course the relay will switch off and the battery will discharge, but it discharges so quickly that we can't really see what's going on. If I bring these parameters down a bit, I might be able to get this to kind of a 50-50 mark space ratio of charging and discharging. I'll just have a little play with that. Okay, that's a bit better. I've got 12.7 at the bottom, so when it hits 12.7 it switches off. 13.7 at the top, so when it hits 13.7 it switches the relay off. When it drops down to 12.7 it turns the relay on. The flashing display does not help, so every time the display flashes I'll press one of the buttons which stops it flashing. So we're dropping to 12.7, relay turns on, we go up to 13.7, relay turns off, we fall back down to 12.7, relay turns on, and so on and so forth. Now it is quite difficult showing how this works with a battery, so I'm actually going to switch to a supercapacitor. So this is a supercapacitor. It's a set of 6 supercapacitors in series. They are 2.7 volts, so that gives you 16.2, I believe it is, volts. Now I've also got this bulb across there because we want it to discharge reasonably quickly. I think the mean discharge current of this is about 0.5 amp, so we'll set the power supply to 1 amp, and that should give us a nice switching between charging and discharging. So I'm just going to attach these cables, which I also made up earlier. Right, okay, I'll connect that up to the charge controller and we'll see what happens. And what happens is we have no battery encountered because this supercapacitor is at 0 volts, and you really wouldn't want to connect it with some voltage across it. Well, you could connect it, but you don't want these two wires to short together if this had some voltage across it. So what do I do about the fact that it says no battery encountered? I need to get this up to the sort of voltage that a battery would be at, so that we can get this relay to switch on. Now I can do that by using a piece of wire to short positive to positive. After all, that's all the relay does. But if I do that, I am going to temporarily, while this capacitor is at 0 volts, take the whole system voltage down to 0 volts. This will go into constant current and output close to 0 volts and start charging the capacitor up. But what it means is that this thing will blank out temporarily. So let's do that. What's the current set on here? Let's set it to 15 volts and I'll put it to 1 amp. Ooh, spot on. So 1 amp, 15 volts. Okay, let's turn that on and we'll short across these relay contacts. This display will blank out. This will immediately go into, well, this voltage will shoot down and it'll go into constant current. And then we'll try and lift the capacitor voltage up to something that we can use. I can't remember what the battery encountered voltage is, but I suppose it's going to be similar to the minimum input voltage of this. So about 6 volts. Okay, let's short that out. I think I had a loose connection on the supercapacitor, but okay, short out the relay device. You can see its display goes off and the voltage on the power supply's LED is the supercapacitor voltage, and I probably need to get that up to about 5 or 6 volts before this device will say that it's encountering a battery. That's gone a bit mad with 2 or so volts on the output, 1.5. So let's carry on lifting that up. Okay, we're up to 4 and a bit volts, and you can see the backlight coming on the display, and now we can see the digits, and it's measuring the relay just pulled in. The relay light was on, but the relay hadn't pulled in because the voltage was too low. The measuring says 4.8 volts, but it hasn't actually got there yet, so I don't think the microcontroller is measuring reliably yet. So we'll wait until the microcontroller starts to measure the battery voltage, or in this case the supercapacitor voltage, reliably, which it does appear to be doing now. And that's come up to 5 point something volts. So I can probably take that off now. Now the relay is on, the red light is on. So in fact the supercapacitor is now being charged, and I will take it up to about, well, 15 volts this is set to, so it will go all the way up to 15 volts. This is pulling 1 amp. So let's wait for it to go all the way up to 15 volts, whereupon, well, what are my set points? If I press the middle button, I can see the upper set point is 13.7, the lower set point is 12.7, so up 13.7, down 12.7. Op and dop, as I say, are timers. We're not using those at the moment. The battery voltage is currently, the supercapacitor voltage is currently 6 volts. Let's let it climb up. Now it's all slowed down, and that I think is because the bulb brightness is increasing, so it's taking more and more current, so the rate of charge is slowing down. I think what I'm going to do is set the upper voltage for something like 11 volts, the lower voltage for something like 9. So press and hold the middle button. The relay turns off when you're setting, and you get the set symbol to show that you're setting it. So let's bring that down to 11 volts, like so, and we'll set the down voltage to, let's go for 9 volts, like so. That's 9 volts. We're not worried about the 2 timers, so I'll press and hold that to program it, and now we'll wait until the supercap gets up to 11 volts. So it's heading for 11 volts on the supercapacitor. When it hits that, the relay will switch off. I'll just stop the flashing, and we can watch the voltage on the supercap come down. But I took the bulb out actually to speed that up. I'll put that back in now, otherwise the supercap won't discharge very quickly. We want the supercap to get down to 9 volts. That's perhaps a little slow. I really want it to go a little bit quicker than that, because I've got to think of things to say to fill these gaps. So maybe I'll reprogram it for about 10 volts at the lower limit. Anyway, it's heading for 9 volts. Whereupon, that's the lower limit of course, whereupon the relay will turn back on and the supercap will charge back up. Now notice this thing here, which is the percentage. This is simply the percentage between your two set points. So between 9 volts, which is my lower limit, and 11 volts, which is my upper limit, it will tell you the percentage you are between those 2 points. So 9.6 is 30% of the way between 9 and 11. I think I will speed this up a bit. So I think we'll go for, say, 10 volts at the lower level and 11 volts at the upper. The relay turns on because we're well below the lower limit of 10 volts. And notice that the percentage now says 0 because we haven't even hit the lower limit of 10 volts. And until we do, it can't calculate a percentage between 10 volts and 11 volts. It will now be 10% per tenth of a volt. So as soon as that gets up to 10 volts, we will hit the range at which it will calculate a percentage. So 10 volts is 0%, 10.1 volts will be 10%, 10.2 volts will be 20%, and so on. Okay, I'll speed this section up as we go up towards 11 volts. Right, 11 volts is the upper parameter, so that's the point at which you want the relay to switch off, because you're basically saying my battery is fully charged at 11 volts. Stop the charging. I'm going to stop that flashing. We can now watch it fall down. Of course, it's falling down because of this. This is a 24 volt brake light bulb. So it falls down towards 10 volts, at which point the lower threshold is hit and the relay turns on and we charge back up again, and this will just oscillate between those two numbers indefinitely. It's a little bit slower charging, isn't it, than discharging? Perhaps I'll bring all the voltages down a bit. Now I should be talking about the other features in here. The bottom button, single press, is almost like a safety override. It just turns the charging off irrespective of where you are in the set points, and you can see that it will drop below 10 volts, won't switch back on because there's an off override. If I switch this back on again, then we're back into the relay comes on at 10 volts or below 10 volts and relay turns off at 11 volts. This shows the percentage of the range you've set. So mine is 10 to 11 volts. This shows the percentage. If you press the upper button, single press, it shows a timer, and it shows it in, this says hours, and it is hours on the left actually, so hours and minutes. Now with the supercapacitor things are happening quite quickly, but when you're charging a battery, this timer will tell you how long that battery has been charging. I think it also tells you how long it's been discharging. We'll see actually when we get to 11 volts whether this timer resets. No, I don't think it does. I think it shows you what the charge time was. I don't think it starts another timer to show you the time with the charger being off. Let's find out. So if hit 11 volts, I'll stop the flashing. Any button I think stops the flashing. Yes, it holds the value of how long the charger was connected to the battery, so it doesn't tell you how long the battery was disconnected. 10 volts and it switches back on. Press the middle button briefly and it simply shows you the parameters. You're not changing them, you're just viewing them. So up 11, down 10, op 0, dop 0. So I'll briefly go through the long press items. Remember, short press overrides the relay system and just simply turns it off. Long press on this bottom button gives you the option of low power mode. So now we're low power on, and I think all this does is it turns off the backlight to the LCD after a period of time, so it doesn't do a huge amount. Low power off, that means the backlight will stay on all the time. Now if you long press the top button, you actually change the mode from charge controller mode to discharge controller mode. So I'll do that in the video where I show discharge controller mode. Let's get rid of the flashing, and of course long press of the middle button we've seen before. It allows you to set the parameters for upper, lower, and now op is overcharge protection. You can set a time in hours and minutes. So in fact, I think what I'll do for the second field is I'll simply set 1 minute overcharge protection timer, and DOP is a delay when it hits the maximum voltage. I don't fully understand the purpose of DOP, but we can have a look at that in a moment. So OP sets a countdown timer. It's in minutes, so we can't really see it working terribly well here, but I'm hoping that the countdown timer will time out before we hit the upper voltage, which I believe is set to 11 volts. Yes, that's almost certainly going to happen. And then when the countdown timer elapses, and this will go to 0, I think it turns the relay off even before you've reached the upper voltage. So what this appears to be is that you can set your current controlled charge power supply to charge your battery and switch off at a certain voltage, but if the timer times out before that voltage is reached, then this will also switch off. So I think it's a timer to limit the total charge time, and you can see that it's saying HEA. I've no idea what that is. Yes, HEA, what's that? Now it's not on the listing for this device, so I'm going to have to guess. Is it something like heat? Well, there are no temperature sensors or temperature monitors on this device. Could it be health or hearth, or perhaps heathen? Yes, I don't know. So I think I'm going to call this video here, because I clearly don't know all of the stuff that this device does. I'm tempted to say health, actually. I wonder if it's because the timer timed out even before the battery hit its upper limit, but I don't know. Let's stop that flashing. Oh, that also stops the HEA flashing, which is a bit of a shame. Okay, so you can basically see how this thing works. In this charge controller mode where it says in, it simply switches off the relay when the battery reaches an upper limit and switches the relay back on when the battery hits a lower voltage limit. OP is an overcharge protection timer. DOP is, well, it's described as a delay turn on time. I'll have to go into that in more detail in the next video. But yes, that's it for the moment. What do you think HEA means? Cheerio.